to Calculus Universalis. In this lesson, we're tackling one of the most tested topics in AP Calculus, motion in a straight line using derivatives. We'll break down how position, velocity, and acceleration are connected, and what it means when a particle is speeding up or slowing down. And then we'll walk through three key examples together. Let's jump in. In calculus, motion problems revolve around three core functions: position, s of t, velocity, v of t, and acceleration, a of t. Now v of t is equal to s prime of t, a of t is equal to s prime prime of t, and a of t is equal to v prime of t. So you can see the correlation here. The position is the location at time t, the velocity is the derivative of position, and the acceleration is the second derivative of position. So think of velocity as the rate of change of position, and acceleration as the rate of change of velocity. Some important notes to note are, if v of t is greater than 0, the object is moving to the right or forward. If v of t is less than 0, the object is moving left or backward. Also, if v of t equals 0, the velocity is at rest, and when v of t and a of t have the same sign, equals positive, v of t and a of t equals positive or negative, negative, and they correlate, then the object is speeding up. If they mismatch, like positive and negative, or negative and positive, then the object is slowing down. Let's practice with three key examples, and then make sure to pause them before I go over the answers. Problem 1. Suppose s of t equals t cubed minus 6t squared plus 9t. When is the particle at rest? To solve this, we set s prime of t equal to 0 to find velocity. V of t, set this equation equal to 0, which is going to be 3t squared minus 12t plus 0. When you set v of t equal to 0, you get t equals 1 and t equals 3. So these are the times where the particle is at rest. Example number 2. Given v of t equals 3t squared minus 12t, determine when the object moves left or right. So basically we have to see when the velocity is positive or negative. So let's solve by setting this equal to 0 to find our critical points. Now when v equals 0, t is going to equal 0 or 4 to make this statement true. Now we have to test these intervals. So when we test these intervals, we can see we have 0 and 4 on our timeline. If we plug in, let's say, a 2, is it going to be positive or negative? Negative. If we plug in something above 4, 5, is it going to be positive or negative? Positive. And if we plug in anything less than 0, can't, because there is no negative time. So that is our second example. Now for our third example, we are going to go over, let v of t equal t squared minus 4t, and then a of t is going to equal 2t minus 4. When is the object speeding up, and when is it slowing down? To find this, we check when velocity and acceleration have the same or opposite signs. First, when we find v and t set equal to 0, this yields t equals 0 and 4, And then we set a of t equal to 0 to find our critical points. This happens when t equals 2. So now we make a little chart for velocity and for acceleration. 0, 4. And we plug in numbers to each of the equations to find if it's positive or negative. And then wherever they correlate is where they're speeding up. So, from negative infinity to 0, we find that it is speeding up because they have the same sign. They are both negative. Up until 0, and you can make little dots to overlap. So we find that it's negative here on both. Now let's try from 0 to 2. So 0 to 2, v of t is positive, and this is negative. So here it is slowing down. And then from 2 to 4, they are both greater than 0, so it's speeding up. And then for 4 to infinity, they are also both greater than 0. If you plug in a number like 5, here plug in a number like 3, plug in 1, and plug in a negative 1. And then this is where you find where it is speeding up and slowing down. We're at our final answers here. Speeding up, up, negative infinity, 0, 2, infinity, down, equals 0 to 2. And that is our final answer. I hope you guys enjoyed this video, and AP loves this stuff, so make a chart if you need to. Now let's go over some key points from the video. The derivative of position is velocity. The derivative of velocity is acceleration. When they have the same sign, they're speeding up, and when they have opposite signs, they're slowing down. When velocity equals 0, the object's at rest. Now for your challenge problems, given a position function, find total distance traveled. Second, find when an object changes direction. Third, determine when it's slowing down versus speeding up from velocity and acceleration functions. In the next video, we're moving into local maxima and minima using the first derivative test. Hit subscribe if you haven't already. I'll see you next time.